This is the transpose stable state. So this is the number of states, right? And this is the identity matrix. Okay, good. So let's try our previous example. We have two states, right? 1, 1, 1 and -1, -1, -1. So both the notation are y1 and y2, right? So W is calculated as y1, right? Times
Y1 transpose.
y1 transpose, good. Y1 transpose plus, okay, because we have a summation here, right? -1, -1, -1. Sorry, sometimes it's a bit lagging. All right. So y2 times y2 transpose, right? Minus,
2.
okay, I put this down here, right? So you have how many states?
2 states to
Alright.
memorize.
2 states, right?
Yep.
So this is 2 times the identity matrix, which is 3 by 3, kan?
Yes.
Okay, so why 3 by 3?
Because we have 3 elements in the
Okay, because you
2
have
states.
3 elements or 3 vectors or 3 neurons for each states, right? So 3 vector. So that's how you get the identity matrix, right? So let's calculate. So weight is calculated as, so the first part here, I'll color this using a blue color, right? Here. So this part is actually, if I'm not mistaken, is 111, right? Plus 111. Okay. All right. And then, so this is the same as this one, right? And then you minus 2 times identity matrix, this one. So it will become something like this, 2, 2, 2. Right. So the answer would be 0, 0, 0. So it will look like this. Right. So this is the final weight of our Hotfield network. Right, so we have already finished step number 1, which is storage. Okay, so step number 2, siapa orang lain pula?
Testing.
Step number 2, testing. So what happened is that testing?
Compare.
Okay, testing, compare.
Nak tengok sama ke tak dengan stable state.
Okay, the input and output, kan? Okay, the Hotfield network should be able to memorize the stable state, right? So macam mana kita nak tahu network ni able to memorize the stable state? So let's say this is our Hotfield network. Okay. So whatever the input given, kan, input 1, input 2, and input 3 must produce out 1, out 2, out 3. So the input must be equal of the output. Right, for example, if we were to present the network with a stable state Y1, the output will be the same. Okay. Sini X lah. X1. Okay. And you have to test for both. Alright. Test for all stable state. Alright. So if you, in our case, we have 2 stable state. So we have to test both. Right. So let's do one. So in order to produce the output, okay, this one. So let's say the output is X. So how do you produce X? What's the equation?
Sine
Sine
weights multiplied by the input. Is
weight
it?
multiplied with input minus threshold, right?
Yeah.
But our bias is zero bias. So a zero bias multiplied with a threshold, we get a zero threshold lah. So automatically we would cancel this part. So part ni tak ada. So now we have a simplified equation which is sine weight times input. Right. So ni bukan identity matrix lah, ni input. Okay. Alright. So let's I change lah. I don't want you to get confused. So I put Y here. Okay. Right. So what is Y? So Y is the stable state lah. So now let's try out one stable state equals to sine of this is the weight, right? Times 111. So you get sine, okay, because these two value multiply with these two ones, right? Okay. Sama juga macam yang ini. All is multiplied by 1, so you get 4, 4, 4. Right. So applied to a sine function, you get all 1, 1, 1. Okay? Okay?
Okay.
Agreed.
Alright. So how about the next one, which is for stable state -1. Alright, so let's try it out. So let's say X is the output. So sine again the weight value 0, 0, 0. Okay, times -1, -1, -1. So you'll get sine all negative, right? -4, -4, -4. Am I right? So you get all negative. Okay tak?
Okay. Okay, sir.
Alright, so no dispute, right? Okay, so that's it for step number 2. So step number 2 is done. Step 2 done. Okay, how about step number 3? What happened in step number 3?
Retrieval.
Retrieval. Alright. So what happened in retrieval?
We have to use the unstable states.
Yes, use unstable states to find the stable state, right?
Yes. Yep.
Alright. So an example of unstable state or probe is any states that is other than the stable state. So let's say this is a stable state. Okay, so other than this would be one vector change to a minus, right? So this one. So this is one example of unstable state. So we try out to produce the output to the network, kan? Betul tak? So masukkan dalam network and we want to find out whether it can reach the stable state, right? So let's try it out. So x equals to sine 0, 0, 0. Am I going too fast?
No, sir.
Alright, so -1, 2, 2. Sorry. 2, 2 datang. This one is 1, 1. Okay, so we'll get, for this one, we'll get a positive, right? A 4. Okay, and for this one, we'll get -2 minus 2, right? Betul tak? This one multiplied with this one, -2, and this one is multiplied with this one, we'll get 2. So this should be 0, right? Same with this one. Am I right?
Yes. Yes, sir.
Okay, because the sign function for Hn, okay, states that if the output is 0, it would refer back to the original input, kan? Tak, original input dia 1, 1. So -1 would be 4 ni would be a positive value. So the answer would be 1. Okay, because of positive value. And this is not because of 1, because the previous value is 1, right? So this is the answer. Okay, however, for this output, all right, it doesn't match the input, right? The input is -1, 1, 1, right? So it doesn't match. So what happened? The output become the next input. Okay, so it iterates lah. So the network iterates, kan? Ni dia pergi kat sini, ni dia pergi kat sini. We call it feedback loop. Alright. So you boleh lukis macam ni ataupun you boleh lukis macam ni. Okay, ni it goes here. This one it goes here. This goes here. Right. So it doesn't matter. You lukis macam ni boleh, macam ni pun boleh. Right. So because this one becomes the new input. Okay, this one. So kita dah buat kat atas tadi kan. So we know that when the network is presented iteration sama dengan 1, so this is iteration 1, iteration 0, sorry, iteration 0. Okay, so for iteration 1, if we try to find out sign, oh sorry, laju sangat, sign 111, we would get 111, and as the input is the same, so we stop at this iteration. Alright, Okay. Can everybody do the calculation now? Boleh?
Yes, yes sir, makin faham.
Any question? Any question from other students? Ada tak student lain yang tak faham, yang rasa-rasa macam somewhere you need me to clarify?
Tak ada sir, faham sir.
Okay.
Faham sir, insyaAllah.
Alright, so
Sir,
yes.
I ada questions.
Mhm.
Yang tadi sir bagi yang prop tu, yang unstable state kat atas tu,
Mhm. This one. Mhm.
yang atas tadi, yes. Yang itu memang sir decide sendiri ke memang dia bagi?
Okay. Any values that is other than the stable state will be considered as an unstable state. Sebab when we calculate the weight, we only use two value, which is the stable state, 1, 1, 1, -1, -1, -1, which is considered as the stable state. Maknanya kita, those two values are the value that we want to memorize. Kita nak memorize dua value tu. Ini contoh yang kedua. So, see nampak tak fundamental memory dia, stable state dia ada 3. So, ini yang dia nak memorize. Okay. Kalau kita tengok dekat table yang ini. Okay. So, yang bahagian dia saya dah terconteng dah kan. Sekejap, saya padam sekejap. Nak bagi you faham kan. Okay. It shouldn't take long. Okay. So, this is the stable state we have memorized. Okay. So, stable state Y1, stable state Y2. So, selain daripada Y1 dan Y2, kita panggil sebagai unstable state ataupun probe. Dia maknanya semualah untuk all possible state. Selain daripada tu, dia adalah unstable state. Tapi untuk contoh ni, because kita ada 3 je for bipolar 3 vector, memang combination dia hanya ada 8 saja. Okay. Kalau bipolar 2 vector ada berapa combination? Siapa boleh jawab?
4 vectors.
Yes, 4 vector. Dia macam binary juga. Sebab dia tak ada 0. Dia either 1 or -1. Okay? Aina yang tanya tadi.
Okay. Okay sir.
Okay,
Thank you.
did I answer your question?
Yes.
Okay. Alright, so again, I already shown you this one. Mana ni? Yang ini. Okay. Have you all tried to do this exercise? Supposedly yang ni you buat sendiri kan? Dah buat dah? Senyap je ni tak buat tu.
Belum lagi sir.
Okay. So,
Sebab apa? Bersiapkan group project.
okay, tak apa.
Sir.
Alright, so I want you to do this. Okay, yang ni kena buat. Kenapa saya cakap kena buat? Sebab you want to test your understanding, right? You want to test your understanding of how to do the calculation for the Hotfield network. So this is your own exercise lah. Dia tak ada markah, tapi bila you buat, you akan lebih faham. Okay. So this again, this is the fundamental memory. Okay, bila fundamental memory je maknanya the HN must memorize this. So dia ada how many vector? 1, 2, 3, 4, 5 kan? So network dia, neuron dia 5 lah. Okay, automatic you tahu. Right, so macam mana nak calculate dia punya weight? Weight dia calculated as X. Ni X kan? Notation dia tadi Y. So X M times X M transpose minus M times I. Written as x1 times x1 transpose plus x2 times x2 transpose plus x3 times x3 transpose. Nampak tak beza dia macam tadi? Tadi tu ada 2 je kan, sekarang ni ada 3. Minus m times identity matrix, yang ni 5 by 5. Okay, m dia 3 kan, betul tak? Okay, if you manage to do this, you will get this. Alright. Alright. So supposedly if you do step number 2, which is to test the network, it should do fine. Okay. Bila you dapat weight ni, our Hotfield network should be able to reproduce the fundamental memory if it is presented to the input. Maknanya input dia macam ni, dia akan hasilkan output yang sama. Tetapi bila kita present dengan probe yang baru, okay, probe yang baru which is this one, only one value is a negative value, so supposedly it will converge to the fundamental memory x1. So that is not the case because dia kata untuk contoh yang ini dia recalls x3 which is a false memory kan. You kena buat lah yang ni, you akan tahu. So apa masalahnya? What's the problem? What's the problem of the Hotfield network? So the Hotfield network has storage capacity problem because the storage capacity is limited. Kenapa limited? Why does the memory of the Hotfield network is limited? Because one, okay, yang ini Hotfield network is a single layer network. Itu satu. Yang kedua adalah a Hotfield network represent an auto-associative type of memory, and although it can retrieve a corrupted or incomplete memory, but cannot associate it with different memory. So easier for me to explain. Just understand that a Hotfield network has a limited capacity of a memory. So macam mana? How do we solve this problem? Of course, we don't want to leave it like that, right? So the next the next algorithm that we will learn is bidirectional associative memory. Okay, so mungkin kita akan tengok bidirectional associative memory ni next week ataupun esok lah. Okay, tengok sepatutnya esok ada orang lain nak gantikan saya tapi ada problem sikit. So if if that the person that is supposed to to replace me tomorrow cannot be in your group session, so esok saya akan sambung bidirectional associative memory. Otherwise orang tu dia akan ajar you macam mana nak calculate the cohonent. Okay, alright. However, saya explain sikit because I have already explained to our previous class, right? So remember my example about document restoration? Remember? Ingat lagi tak? Yang contoh yang sebelum ni yang saya bagi.
Ingat.
Kan? Contohnya Aristotle kan? Dia ada dia punya manuskrip, contohnya dia tulis saya suka kan nasi. Okay, so as time evolve, right, so the manuscript ni dia ada missing information, dawat hilang kan, ada pin blotch and so forth. Alright, so what does a Hotfield network do is it takes up a perfect symbol, alright, ambil perfect symbol ni and diambil sebagai fundamental memory. So this is tulisan Aristotle contohnya lah untuk A yang perfect, right? So dia nak retrieve A yang lain ni lah, yang tak perfect. Okay, so dia dapat weight, dia ambil yang A yang perfect ni, dia dapat weight dia. Alright, so what happen is that dia ambil pula data yang lain yang missing. Alright, so it's the same A but not complete. Alright, so supposedly dia ada macam ni. Alright, when presented to the Hotfield network, okay, it will produce a more complete version of the network. Okay, but probably tak sama kan, the input and the output is not the same. So what happen is that the output becomes the input. So again, the output becomes the input, and again the network will produce another output and tries to perfect the symbol lah. So and then dia check lagi sama tak? Tak sama. So tak sama, dia pergi lagi. So now the perfected symbol becomes the input and finally it converge lah. Sama. So because the input and the output is the same, the Hotfield network is considered as a converged network. So we know that some part of the network is rectified as the letter A, contohlah. Okay, but of course a complete algorithm would be more complex than this because dia ada banyak lah, there's a possibility of a false memory, so they check the whole sentence pula, kan, ataupun the whole word. Word ni, what are the possible word? Highest priority will be the word. So mungkin dia jadi benda lain kan. Suka ni mungkin is perkataan lain, saka ke contohnya, suka and saka kan. Which one? Is it suka or saka? So dia tengok pula the whole sentence, algorithm dia. So dia ada macam percentage of probability which would be the correct word in that sentence. Alright, ada tak saya saka makan nasi ataupun saya suka makan nasi? So which sentence has a higher probability of having the correct word in that particular sentence? Right, so a complete algorithm would be a combination of other algorithm as well. Dia work together lah. Dia bukan saja Hotfield network, ada juga some sort of case based reasoning ke ataupun rule based ataupun fuzzy. Is more complex than that. Alright, boleh faham this example?
Boleh faham sir.
Okay, even though the example that I'm giving is an image, but is for Hotfield network not necessarily the train memory must be an image. Okay, train memory can also be a pattern or behavior. Contoh pattern and behavior is you lah, you as a user. But another example yang lebih mudah untuk kita faham adalah virus kan. Virus ada behavior tak?
Ada.
Kan? Orang yang sama je yang jawab, orang yang lain tak tahu.
Oh,
Malu.
sorry sir.
Tak apa.
Sorry sir. I got excited sir.
Tak apa, no problem. Cumanya saya suka kalau you all berebut-rebut nak jawab. Kamarul, thank you for answering. Right, please don't hesitate to answer again. Right, but then again, virus have behavior, right? So different virus behave differently. Betul tak? Ada virus yang take up memory, ada virus yang dia duplicate itself, ada virus yang takes up your network bandwidth. Ni waktu ada yang kat belakang tu somebody yang tu bukan virus. Alright, So sayang tak nak go outside. Okay. Lepas tu my point is virus has behavior lah. So all that behavior can be recorded into a log kan. Selalunya kalau if you know about viruses and if you want to understand about virus, you put it in a sandbox kan. Betul tak? Have you heard about sandbox? Dah dengar sandbox?
Virtual
Tak pernah
machine?
sih.
Is it something like that?
Yes, it's something like a fake operating system.
The
Okay.
VMware. No. Okay.
Macam tu lah. Tapi but the sandbox will have a log of the virus behavior. So dia ada log lah. Dia guna port apa, dia how big is the size of the virus, and virus ni cuba access which program, adakah dia cuba untuk duplicate diri dia sendiri, ada dia guna command apa, dia guna command copy ke, which port yang dia pakai, and so forth. Banyak lah. There's a lot of information, and ada yang dia tak buat pun. Alright, so it's more of some sort of log checks. Alright, apa yang virus ni buat. So different virus has a different logs. Okay, dia ada different log checks. Alright, so all these are in text kan, dia dalam bentuk teks. Then of course you understand in a machine learning punya algorithm, you need to calculate the input. Alright, so because text it's very hard for you to identify apa tu, the textual punya references tu lah. Okay, so what you can do is that for each behavior it can be either is this behavior exist or not, which is a binary kan, betul tak? Maknanya virus ni ada tak buat copy function, yes or no, right? Adakah virus ni menggunakan port 8080 contohnya? Adakah virus ni menggunakan port printer? Adakah virus ni menggunakan memory yang banyak? So all that can be converted into a binary value. However, the problem is that because there's so many behavior kan, banyak behavior dia, so bila kita convertkan kepada binary value, dia akan ada string of binary value lah. Dia macam pattern, a pattern of yes or no. Alright, which is 0101 tu lah, macam ni, and so forth. So each of this behavior shows a different pattern of a different virus, right? So and virus dia evolve tau. Virus ni dia macam in order to avoid being detected, probably pattern dia sebelum ni dia tak buat yang ni. Dia buat yang ni, dia guna port lain, right? So dia switch. Jadi macam ni. So dia jadi virus lain lah, tapi sebenarnya dia virus yang sama. Okay. So our part of doing machine learning is so that our program can adapt. Alright, walaupun a slight changes to the virus behavior, we know that okay, this is the same virus, right? Nampak tak? Macam how the previous the previous way of updating your firewall ataupun dia punya virus punya antivirus tu kan, you have to update the virus punya file tu kan, barulah antivirus tu tahu this is a virus. But if you have some sort of adaptive antivirus, alright, so even though the behavior changes, it can still understand this is probably the same virus. Alright, so the main virus is the stable state. Nampak tak? Main virus akan jadi stable state. Selepas tu dia akan buat some sort of checking lah, and the checking must be in terms of several iteration. Maknanya iteration dia kalau lebih daripada 2 ataupun 3, mungkin it's something else. Right, kalau terlalu banyak iteration untuk sampai ke stable state, of course bila you run a different behavior, it will eventually come to a stable state. Tapi if the pattern is too different, maknanya pattern dia berbeza, sangat besar beza dia, we know that is probably something else. Tapi kalau we have run macam 2 kali contohnya iteration, and we found out that it is similar to a stable state that represent a virus, then that is probably a virus. Tu contoh yang lain yang saya boleh bagilah selain daripada image. Saya suka bagi contoh image supaya you faham. Tapi saya tak nak you all confused dan terlalu terlalu terikat sangat dengan contoh image sahaja. Alright, because machine learning is more than that. Okay, boleh?
InsyaAllah.
Boleh sir.
Boleh sir.
Boleh sir.
Okay, so ada juga macam contoh yang lain atau sound sampling. Right, sound sampling. We want to sample sound. Okay, sound with noise. Kita nak tahu, okay, sound ni sebenarnya bunyi apa. Okay, so we want to remove the noise. So, but we also need a stable state where the similar sound without the noise, right? So that's how we do some sort of noise correction and all. So boleh juga guna Hotfield network, right? But of course still the problem lingers, right? Sebab masih lagi dalam otak you cakap, yes, theoretically a Hotfield network can do so much, but again we have to get back to the memory problem, right? Memory problem ni yang masalahnya, sebab kita tak boleh ada, bila kita tak the memory is limited, then we understand that we cannot do much, right? Even though theoretically we understand that Hotfield network can do this and that. It's possible for Hotfield network to do this and that. But when we encounter the memory problem, then we have to do something about it. Alright. So to solve this is actually to do bidirectional associative memory. Bidirectional associative memory. So what does bidirectional associative memory do? Okay, I will use the same example. Instead of a network that memorize the input to the output with the same vector, okay. So bidirectional associative memory has 2 layers. Contohnya macam ni, 5 neuron reduced to 3 neuron. So a bigger A will produce a smaller one, a smaller sample. Alright, so that's how bidirectional associative memory does. Okay, cumanya dia macam still macam supervised network lah, sebab dia ada label. Right, so this is the label, this is the input. Right, so what happen is that Hotfield network tries to associate the input to the output. Dia akan associate input to the output. So bila dia dah memorize, okay, A yang besar ni ke A yang kecil, given the same example, kan, saya bagi contoh yang sama lah. So if let's say I have an incomplete A saya ni tak complete, macam ni contohnya. Okay, so presented to the bidirectional associative memory, dia ada 2 layer, right, macam ni. So dia akan hasilkan A yang kecil, yang perfect lah, supposedly. Okay, adakah habis kat sini? Tidak. Okay, apa yang berlaku adalah bidirectional associative memory, dia bukannya feedback loop tau, dia melalui network yang sama. So instead of having a forward propagation, dia buat back propagation juga. Tapi kita tak panggil back propagation lah. So input menghasilkan output. Output pun boleh menghasilkan input juga. So what happen is that a perfect smaller A ni, dia akan menghasilkan output A yang baru, yang perfect. Alright? So dia macam itulah. Dia ke depan, lepas tu ke belakang. Dia ke depan, dia ke belakang. So this is supposed to solve the memory problem, right? Because dia ada a deeper layer, right? Some latest algorithm of a bi-directional associative memory have so many layers. A yang besar akan menghasilkan A yang lebih kecil. Dia macam tu. Ada yang lukis macam ni pun ada juga. So dia ke sini, pergi sini. Tapi sebenarnya dia balik ke sini sebenarnya. Right? Tapi kalau you baca artikel about bi-directional associative memory, dia tak panggil bi-directional associative memory, dia panggil auto encoders. Right? Yang ini yang the new generation bi-directional associative memory. But bear in mind, it happens something like this, right? Nanti kita akan sambung dengan apa tu? Dengan nota kita yang seterusnya, which is bi-directional associative memory. Sampai sini saja sebab kelas lain pun tak habis lagi yang ni. Sampai kita buat sama-sama nanti, either tomorrow or next week. Alright? Ada soalan?
Sir,
Yes.
apa beza kalau kita guna autoencoders dengan recurrent neural network?
Okay, good question. Apa beza kalau kita guna autoencoder dan juga RNN? So RNN is actually Hotfield network. Ni Hotfield network ni dia awal dia dah cakap dah. Ni. So some RNN should be able to ni awal dia cakap ni. Tengok ni. Ni. Okay, the Hotfield network is a recurrent neural network. Dia ada feedback loop. Okay, tapi untuk autoencoder ataupun bidirectional associative memory, dia tidak menggunakan feedback loop. Dia menggunakan forward direction dengan backward direction. Yang ini saya akan explain lah dalam next class. Tetapi kalau new generation punya program, sometimes dia dah integrate dah RNN dengan autoencoder ni. So kena tengok dekat, macam kalau TensorFlow ke kan, you have to look at the documentation itself, how it actually perform the network. But again, ultimately, when you want to solve a problem, you have to look back to your objective of your dataset. Dataset you nak buat apa sebenarnya? So your objective to solve your problem will determine which algorithm that you should use. Okay, so kalau tak banyak kan dia punya memorization of sebenarnya bidirectional associative memory ni, walaupun dia saya explain tadi dia mengecilkan. Nanti sepatutnya saya explain ni lambat sikit. Tapi tak apa, kalau dah tanya kan. Dia kata kat sini ni. Nampak tak kat sini dia kata, there is also a close relationship between bidirectional associative memory and the Hotfield network. Maknanya RNN dan juga autoencoder ni lebih kurang sama je sebenarnya. So if the bandwidth matrix is square and symmetrical, maknanya input dan output dia sama. Macam ni. kita buat macam ni. Tadi tu dia mengecil kan, macam ni. Sekarang ni dia sama je. Saya buat network dia menghasilkan benda yang sama. Adalah sebabnya. Okay. Ataupun
So sir, macam kalau auto encoder so dia tak semestinya I sekali tu dengan satu node lah kan. Mesti kadang-kadang boleh jadi 5 atau 6 depend on kategori dia lah kan.
yes. Okay. Dari satu saya nak explain kenapa why does this happen? Kenapa kadang-kadang dia kata kalau bandwidth matrix is square and symmetrical, maknanya input dan output dia sama saiz. Kenapa ini berlaku? Okay, jawapan dia adalah dia tak ada label. Okay. Kalau kita tengok contoh yang ni kan, ni belum baca lagi ni. Tapi tak apa, saya explain juga. Nampak tak? Step yang pertama, step dia sama je. Tapi dia ada label, dia ada input. Dia macam supervised network lah. Okay, some people would also categorize Hotfield network as an unsupervised network. Kenapa dia kata unsupervised network? Sebab dia tak ada label. Kan? Betul tak? Ada tak label dia? Kita tengok balik ke atas. Stable state. Panjang cerita yang ni. Mana baiklah. Ni. Ada dua je kan stable state kan, dia nak memorize. So the label is actually the input itself. Input dia adalah dia punya label. So bila dia tak ada label kan, kalau you tengok definition, go and find, Google sekejap, define supervised learning, right? So kalau you pergi tengok definition of what is the meaning of supervised learning, dia kata as a subcategory of machine learning and AI, and it is defined by its use of label dataset to train algorithm that to classify data or predict outcome accurately. So bila dia tak ada label, of course dia akan jadi unsupervised, kan? Betul tak?
Betul.
So untuk Bi-Directional Associative Memory, dia ada label. Ni pula kan, tiba-tiba ada label pula. Ni label dia. Ni label dia. Ni. Tetapi kalau label ni tak wujud, sebab in some situation tak ada label, right? Balik pada contoh yang macam dokumen punya apa tu, retrieval ni kan, macam ni. Adakah kalau kita buat version yang smaller of A ni menunjukkan is a correct version of that text, alright? So kalau you nak preserve, if you want to preserve the same samples, alright, so you may use the input as the label itself. So the input becomes the label. Of course without label, so dia akan jadi unsupervised. So don't get confused, walaupun dekat yang saya ajar ni apa tu, saya tak really specify that we are learning unsupervised learning, because for Hotfield network and Bi-Directional Associative Memory is actually a bit of both. Dia dah duduk kat tengah-tengah. Sebab tu dia kata recurrent neural network. Okay. Tapi nanti bila kita go further into a real unsupervised network, macam Cohen K-map, right? Ataupun competitive learning, right? Yang itu dia memang unsupervised learning. Okay, which we will learn later lah nanti. Okay, boleh?
Boleh, insyaAllah.
Did I answer your question?
Yes sir.
Alright, okay. Ada lagi soalan yang lain?
No questions from me. Thank you.
Okay, so if you don't have any question, all right, so I think I'll end our session, and so that you can focus on your mini project. Okay, you can have the extra 40 minutes. Yes, Kamarul?
Sir, is it acceptable if I do Chinese MNIST dataset?
Yes, I would like to see that. All right, even if you use Chinese MNIST dataset ataupun Arabic ke kan, ataupun Japanese ke, please do share the dataset with me, and how would you load the data? I would want to look into that as well.
So is the process similar to the hand digit MNIST dataset that we did? The
Yes.
process of it should be the same, yeah?
Supposedly when bila dia ada gunakan perkataan MNIST tu, the
Mhm.
format should be the same. Maknanya the image should be a 28 by 28 image, and then it is supposed to be grayscale with at least 10 category. But of course kalau Chinese punya simbol tu dia akan jadi, can be more lah. Kalau Chinese number, of course 10 lah, kan? Betul tak?
Okay.
Kalau I've encountered Arabic punya numbering MNIST, it follows the same format, right? But probably the data is different, so you have to load it differently lah. But when you've managed to load the data into a data frame ke contohnya, ataupun NumPy array, it should be the same.
Alright, sir.
Okay.
So just CNN and then use multiple optimizers and different activation functions should
Yes.
suffice the project.
Yes.
All right. Thank you. Thank you.
But nanti I will give out the format of the report, so you just follow je lah report tu. But for now you should have an idea how to create the algorithm first, load the data, produce the output. Nanti the experimental setup tu you choose yang macam you cakap tadi tu, and then how to write the report tu ada template dia I give, and you just fill in.
Alright. Okay. Alright. Thank you so much, sir.
Alright. So any question from the rest of the class?
No questions, sir.
Okay, so let me download your attendance first. Alright, sekejap Alright, so I think that's it. Thank you very much. So I'll share your attendance list. You have to check your name, and I think there's nothing more. So we'll meet again in our next class session. Alright.
Okay, thank you, sir.
Alright, sir.
Welcome.
Thank you. Take care.
Thank you, sir.
Thank you,
Welcome.
sir.
Thank you, sir.
Thank you,
Thank
sir.
you,
Ah, sir. I forgot.
Yes. Mhm.
One of the students asked me, what kind of iPad are you using?
What kind of iPad?
Yeah, she asked.
I think it's supposed to be version berapa ni? Version 10 Version 10 ke version 11? iPad.
Alright. One of the latest models, is it?
I think it's the latest model.
Alright.
This was a gift from my wife.
I see.
Dia ajak saya pergi beli kan. Lepas tu dah beli. Lepas tu dia bagi kat saya.
Okay. Alright. Good to know, sir. Thank you.
Alright. Okay, thank you very much for all everybody that came to today's classes. Alright, so I'll meet you again.
Right, sir.
Okay. Dah tak ada dah.